Hi folks, so what we're going to do in this video here is we're going to work on a question based on the topic of circles. It's actually Circles Chapter 2 in your World of Graphics textbook. It's on page 155 and we're going to do this question here based on a door handle, okay? And the purpose of this question is to practice the principle of getting an external tangent. So constructing an external tangent between two circles. So it's something hopefully you would have covered in class, and we're going to apply that principle to this question over here in this video. Okay, so first of all, reading the question, it says a door handle is shown below. It has two external tangents. Reproduce the diagram to the dimensions given, showing the points of contact. Okay, so first of all, let's look at the question. You can see here we kind of have three circles, radius 36, one here, sharing the same center point, so they're concentric, radius 16 circle here. I've got a radius 24 circle over here, and the distance between the two center points is 120. Okay, so first of all, to start off, I want to identify the external tangents. So I can see the tangents are here and here. Okay, so really the radius 36 circle has nothing really to do with the tangent. So I'm going to leave that out until the end. It's more to do with the circle radius 24 and radius 16. So what I'm going to do is I'm going to start off by doing a line 120 long. I'm going to do a circle radius 24 and a radius 16 to start off with. Okay, so on my sheet, I've already done a line and I've marked the two center points, which are a distance of 120 away from one another. Now on this one, I'm going to mark over 24 to the right, 24 millimeters. And on this one, I'm going to mark over 16 millimeters. Now, very quickly, I'm going to put in two circles there. I'm not going to heavy them in just now. I'm going to put them in as lightly as I possibly can using pen. So you can see there, I've done my construction circles to start off with. We heavy everything at the end. So there's my two circles done, radius 24 and radius 16. Okay, now the next thing we want to focus on is a tangent, okay? Now I'm actually going to very quickly just put in a little tangent up here, a little principle for a tangent. Okay, so hopefully this come in there. I'm going to identify the center point right there. Now you would have covered this previously in another class. So what is the principle of a tangent? If I want to get a tangent to this circle from the point P, step one is I would connect P to the center of the circle. I would then bisect the line that I've just created there. So pick a distance greater than halfway, arc, 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 arc. I'd get the middle there, and then using the center point that I've now found, the middle point of that line that I've now found, I'm now going to then use the distance from here to P, or the distance from here to the center point, and I'm going to swing a semicircle as best I can, and that semicircle then would cut through the circumference of this circle here. That point there is my point of contact for my tangent to P. That's how I create a tangent. That is going to be coming up here when we're doing external tangents as well. Now, in external tangents, what you need to know, okay, if you know external, you can actually use it to help you work out internal as well. But in external tangents, we want to focus on subtracting. That's kind of the key word there. So what do we want to subtract? We want to subtract the radius of the smaller circle from the radius of the bigger circle. So radius of the bigger circle was a radius 24. Radius of the smaller circle was radius 16. If I subtract the two of them, I will get 8. Radius 8 is the one that I want to use. That's my magic number. Now, that radius 8, I want to actually do it inside of the larger circle. It's always going to be the larger circle you're kind of working from. So from the larger circle, I'm going to measure from the center point 8 millimeters. And it can be quite hard to do this now. So take your time with it. From the center to there, I want to do another circle of radius 8. Take your time with it. It can be a little bit awkward when you're doing circles that are quite small. So it takes a little bit of practice. You need a good sharp lead in your compass. So there's my circle of radius 8. Now that I've done this, I want to apply this tangent principle to that new circle, circle radius 8, point P here. Okay, so what do? We connect P to the center of the circle, already done. Now I want to get the distance of the midpoint. Okay, so I could bisect the line, but because we know the distance of the line is 120, very easy for me to just use maths and mark 60. Have I got the midpoint of the line? Yes. So the next stage then was to do a semicircle from the distance from here to P, or the distance from here to the center point of the circle, and do a semicircle. So I'm now going to put my compass point here, distance set out to there, and swing construction or semicircle really lightly until it cuts my circle here. And at that point there, I would then connect that back to here. Okay, that there is my tangent line. Same principle, obviously just different size circles. I'll also connect it to here. That line there is my normal. Now, for the purpose of an external tangent comes in for this question, okay, we've done the construction work. The only difference so far was we did it on a smaller circle, radius 8, by subtracting the two larger circles from each other. Radius 24, radius 16 gave us radius 8. We did that, and then we applied our tangent principle to it. Now, to get the external tangent, there is an extra step. So what we have to do is, we have to extend the normal up like that. And where that cuts through the larger circle right there, that is my point of contact. In there. Okay? Now, what I want to do is, my tangent is going to be parallel, my external tangent is going to be parallel to this tangent inside here. So I'm going to use sliding set squares on the tangent I found, move it up to my new point of contact, and draw that in. And now heavy that in. Okay, now the next thing I want to do is I want to find a point of contact over here. So that point of contact is actually going to be perpendicular to my tangent from the center point. So if I set my set square like this, I'll zoom out so you can see it a bit better. Set square on the tangent, or I can put it on this one. And then what I often do is I just rotate it like this. And now I've got a perpendicular line. And by doing that, I've now found the point of contact here, POC. Another way I could have done it was with the normal line over here, I could have done sliding set squares. Okay, so that's my point of contact got, and I've got my tangents on one side. Now I want to find my tangent, my external tangent on the opposite side. We could go through all that construction again, but because it's symmetrical, we could save our time by just identifying the points of contact on the opposite side. So using my set square and t-square, do a vertical line down from the point of contact and a vertical line down from the point of contact on this side. I've now found my points of contact on the opposite side, and I want to connect those. I've now got my external tangent on the opposite side. And now that I have that done, just zoom out there a little bit, I want to heavy in the rest of the detail of the door handle. So, using my pen now, just make sure. So there's that bit done. A little bit jagged on the pen, apologies. Take your time with it. Just trying to get it nice and heavied. And there we go. That is the actual handle part. Now, if you remember, when I refer back to the question, we also had this part of the door handle, which was a radius of 36 from this center point, and obviously hidden in behind here. So let's get that done as well. So from the center point here, I'm going to mark out 36 to the left like this, from this center point, and put in that part of the door handle as well. So it'll go in like this. Just going to heavy it in as far as there and there. And obviously that is hidden in behind, so nice and light in there, and you can see it. Okay, so there you have it, guys. That is the principle of an external tangent, where we subtracted the smaller radius of the smaller circle from the larger radius to get a new radius, radius 8. We got our tangents to that, and then went parallel to that tangent to get the external tangent on the two circles we really need. Okay, that's the principle there of an external tangent. I hope you found that helpful. Okay.